Scientists made terrifying discovery at Mount St. Helens. After 40 years, Mount St. Helens, a colossal volcano in the Pacific Northwest, has captivated scientists for decades. Renowned for its catastrophic eruption on May 18, 1980, the mountain has been a hub of geological and ecological research ever since. Yet, 40 years later, a shocking new discovery has sent ripples through the scientific community, leaving researchers and the public in awe and fear when Mount St. Helens erupted in the resulting lava, ash, and debris turned the landscape barren for miles around. It was clear the land would take a long time to recover from the eruption, but one team of scientists had an idea about how they could help speed up the process. Sending a few gophers there on a day trip, a routine survey, unveils the unimaginable. The discovery began with what was meant to be a routine survey. Scientists monitoring the volcano's activity employed advanced ground-penetrating radar to map magma chambers and fault lines deep beneath the surface. Initially, the results seemed like a technical anomaly. Voids and structures appeared where none should exist. However, further testing confirmed their presence, and what was revealed defied all scientific understanding. Buried deep beneath Mount St. Helens were vast crystalline formations, pulsating faint electromagnetic signals and composed of minerals unknown on Earth. These formations, resembling a complex network, seemed to respond to external stimuli, raising questions about their origins and purpose. Plant life struggled to return to the area around Mount St. Helens, now under a layer of pumice fragments, while the top layers of soil were destroyed by the eruptions and lava flows. The soil underneath could still be rich in bacteria and fungi. Soil microorganisms regulate nutrient cycling, interact with many other organisms, and therefore may support successional pathways and complementary ecosystem functions even in harsh conditions, a team of researchers explained in a new paper on the area's recovery. With the exception of a few weeds, there is no way most plant roots are efficient enough to get all the nutrients and water they need by themselves, study co-author, University of California, Riverside microbiologist Michael Allen explained in a statement. The fungi transport these things to the plant and get carbon they need for their own growth in exchange. After the eruption, researchers believe that gophers could be ideal for returning it all to the top. They're often considered pests, but we thought they would take old soil, move it to the surface, and that would be where recovery would occur, Allen added. 2 years after the eruption of Mount St. Helens, local gophers were sent to the area in what must have been quite a confusing day trip, even if the animals were not aware of the news. The gophers were placed in enclosed areas for the experiment and spent their day digging around in the pumice. Despite only spending 1 day in the area, the impact they had was remarkable. 6 years after their trip, there were over 40,000 plants thriving where the gophers had gotten to work, while the surrounding land remained, for the most part, barren. Studying the area over 40 years later, the team found they had left one hell of a legacy. Plots with historic gopher activity harbored more diverse bacterial and fungal communities than the surrounding old-growth forests, the team explained. We also found more diverse fungal communities in these long-term lupine gopher plots than in forests that were historically clear-cut prior to the 1980 eruption nearby at Bear Meadow. In the 1980s, we were just testing the short-term reaction, Allen added. Who would have predicted you could toss a gopher in for a day and see a residual effect 40 years later? While the gophers should be praised for their unusual part in the story, the real star of the recovery effort are the fungi. After the eruption, scientists worried that nearby pine and spruce forests would take a long time to recover, as the ash covered their needles and led to them falling off. However, this didn't happen, again, thanks to fungi. These trees have their own mycorrhizal fungi that picked up nutrients from the dropped needles and helped fuel rapid tree regrowth. UCR environmental microbiologist and paper co-author Emma Aronson added, "The trees came back almost immediately in some places. It didn't all die like everyone thought." Comparing the forest to a nearby forest that had recently been cut, thus being devoid of the layer of needles, they found stark differences. "There still isn't much of anything growing in the clear-cut area," Aronson said. "It was shocking looking at the old-growth forest soil and comparing it to the dead area. When researchers drilled into one of these voids, they encountered an unexpected release of gases, including hydrogen fluoride in concentrations far exceeding normal volcanic levels. The crystals themselves were even more baffling, emitting electromagnetic signals resembling coded patterns. Signals that some scientists speculated could be a form of communication or data storage. Further analysis revealed isotopes within the formations not found on Earth, suggesting an extraterrestrial origin. The idea that Mount St. Helens might be hosting alien technology was as thrilling as it was terrifying. The implications and growing threat. As research progressed, scientists discovered something even more alarming. The crystalline network was expanding. The voids grew larger, and the crystals became more complex, correlating with increased seismic activity in the region. This raised fears that the formations could destabilize the volcano, potentially triggering an eruption even more catastrophic than in 1980. Such an event could have global repercussions, including widespread environmental and climatic disruptions. A race against time, efforts to monitor and understand the phenomenon have intensified. Advanced sensors now track the growth of the crystals and their impact on the volcano's behavior. While some scientists speculate the formations are a natural anomaly, others believe they could be part of a dormant extraterrestrial system designed for purposes unknown, possibly energy harvesting or communication. Meanwhile, conspiracy theories abound, with suggestions ranging from secret government experiments to ancient alien civilizations using Mount St. Helens as a base. Whatever the truth, the discovery has opened a Pandora's box of scientific and existential questions. A global phenomenon? Early investigations of other volcanic sites suggest that Mount St. Helens may not be unique. Similar crystalline formations have been detected elsewhere, hinting at a potential global network. If confirmed, this could rewrite our understanding of geology and humanity's place in the universe. This captivating narrative about the crystals beneath Mount St. Helens masterfully blends scientific intrigue with an element of the unknown. Here's a polished version of your story, emphasizing its suspenseful and thought-provoking elements while enhancing readability. Mount St. Helens, a volcano infamous for its catastrophic 1980 eruption, has long been a focal point for scientists. Nestled in the Cascade Range of the Pacific Northwest, it stands as both a testament to nature's power and a site of unending curiosity. For decades, researchers have studied its seismic activity, gas emissions, and topography, seeking to understand its volatile behavior. But recent findings beneath the surface have sparked both wonder and alarm, sending shockwaves through the scientific community. What began as a routine survey led to one of the most unsettling discoveries in recent history: a mysterious network of crystalline formations buried deep within the volcano. These crystals, emitting faint electromagnetic signals and defying known geological processes, are challenging everything we understand about Earth's natural systems. The discovery. During a project to map Mount St. Helens magma chambers, geologists deployed advanced ground-penetrating radar and imaging technology. The data revealed strange voids and structures far below the surface, formations so unusual that initial readings were dismissed as equipment errors. However, Repeated scans confirmed the anomalies. The decision to drill into one of these voids marked the beginning of a shocking revelation. As the drill penetrated deeper, it released gases containing high concentrations of hydrogen fluoride, a highly toxic and corrosive substance. Upon reaching the void, researchers uncovered crystalline structures pulsating faintly with electromagnetic energy. These formations were unlike any natural mineral previously documented. The crystals. A mystery beyond science lab analysis of the samples revealed properties that defied explanation. The crystals absorbed trace elements from their environment, growing and adapting as they converted thermal and seismic energy into electromagnetic signals. These behaviors hinted at an intelligence or functionality beyond natural processes. Some researchers speculated they could be extraterrestrial in origin, especially when isotopes not found on Earth were detected. The crystal's electromagnetic emissions followed coded patterns akin to advanced algorithms. Was this a form of communication, or perhaps a system designed to interact with Earth's geology? A threat beneath the volcano. The formations weren't static. Over time, they grew more intricate, expanding the voids they occupied. Alarmingly, this growth correlated with increased seismic activity, suggesting a potential destabilization of Mount St. Helens' magma chamber. The possibility of an eruption even more devastating than 1980 loomed over scientists and nearby communities alike. Efforts to extract and study larger crystal samples encountered unexpected resistance. The formations emitted energy bursts that disrupted equipment and nearby communication systems, intensifying fears about their unpredictable nature. A global phenomenon? Further investigations revealed the presence of similar crystalline anomalies beneath other volcanoes, including Mount Rainier, Mount Shasta, and Yellowstone. These findings hinted at a global network, raising urgent questions about the formation's purpose. Were they remnants of an ancient event, part of a natural process, or evidence of intelligent design? Intriguingly, ancient myths and records from cultures worldwide described glowing or pulsating lights near volcanoes, possible early observations of these mysterious structures. Could these myths hold clues about the crystal's origins? Implications for science and humanity. The discovery has profound implications for technology, energy generation, and humanity's understanding of our planet. However, the risks are equally significant. Harnessing the crystal's energy could trigger catastrophic geological events, while interfering with an unknown system might have unforeseen consequences. The scientific community remains divided. Some advocate for caution and containment, while others see the crystals as an unprecedented opportunity for advancement. The debate reflects humanity's enduring tension between curiosity and caution in the face of the unknown. The crystals beneath Mount St. Helens have opened a door to a frontier of knowledge and possibility. Whether natural or artificial, they challenge our understanding of geology, intelligence, and Earth's history. As scientists race to unravel their mysteries, the world watches with a mix of awe and trepidation. This journey into the unknown is fraught with risks, yet it promises to reshape how we view our planet and our place in the universe. One thing is clear: the story of Mount St. Helens is far from over. The crystalline structures beneath Mount St. Helens have introduced a new frontier of exploration, blending the realms of geology, physics, and possibly extraterrestrial science. Whether this discovery will lead to groundbreaking advancements or catastrophic consequences remains uncertain. But one thing is clear: the secrets beneath Mount St. Helens have forever changed our perception of Earth and our future.